Yeah, there's a lot of different devices that are out there right now on the purification side. We generally are looking at UV devices, which we see as a passive technology, passive air purification strategy, which means that the intent of that is to clean the equipment, but that inherently is cleaning the air that's going by. In addition to that, we generally kind of lean towards the ionization. Needlepoint bipolar ionization is typical of what we'd use from a purification standpoint. And that's an active air purification stream in which it's going to clean the air throughout the space and within the mechanical systems to purify it as a whole. So, did that answer your question at all?
Yes, thank you.
No problem.
Okay, Brian, so the CDC, especially for K-12 facilities, has recommended that those showing symptoms or signs of COVID be separated from others in the facility. Can you comment on what that should look like? For instance, I know we've heard some places where basically they're just picking a room in the building and they're asking, you know, those students, staff members, whatever it be, to go to that particular space. Is that realistic, or what should they be doing?
Yeah, certainly that, isolation rooms is what those are often called for right now. In the K-12 world, that was part of, DeWine's recommendations that came down, is that every school building should have one of those, an isolation room. And what that should be is a room that is not going to provide any transfer air to other spaces. So you want to understand what happens to the air in that space, how it gets to the return side. Back to the equipment, because putting that person in that one room that might have the case, being an airborne, aerosolized virus, it can go through the mechanical equipment, and another reason to have improvements to ventilation and purification and filtration as well. So having a good understanding of how that room is ventilated is very important. There are some devices like the standalone filtration devices that can be used in a space like that. If the facility does not have a space that is isolated, where it's not going to be expending return air to other spaces, some form of a temporary space that is exhausting directly to the outside would be something to look at as well.
Okay. Anyone have questions for HVAC stuff? Okay, we're moving on to our third topic, being water treatment. So we have Steve, you're up. You'll have to unmute yourself. There you go. So we've been hearing about Legionella Bacteria in school districts here lately. Can you tell us what that is and why it's so dangerous?
Sure. So just in general, Legionella Bacteria is a waterborne pathogen naturally occurring in natural water systems, ponds, lakes, rivers, and basically the dangers associated with that in commercial buildings are you're giving that bacteria a place to thrive and exponentially reproduce based on the way that buildings are designed, based on plumbing codes, temperature codes, and scald protection codes. We're creating an environment inside commercial buildings for that bacteria to literally thrive. And so, the way that it gets into buildings is it's going to come in through the city water. They're not required to test for it. Even if they were, we do a lot of city water incoming main tests in our facilities, and we don't find it at the main because it's at such a low level, it's not detectable coming in from the city. And then once it gets into the commercial building setting, primarily in the domestic hot water, the disinfectant from the city is driven out with the heat and the recirculation of that system. And the temperature, like I said, due to scald protection, is the prime temperature for that bacteria to reproduce and live. So in a nutshell, that's kind of what that bacteria is. There's also other waterborne pathogens out there that don't get as much advertisement as Legionella. Legionella, I think, is the most prevalent that everyone hears about. And I think the reason that we're hearing a lot right now in K through 12 schools is due to, there's been some media on an illness, at a local school district here, that got kind of the headlines pumped up. And then, a month or two later, everyone's starting to open schools up and getting geared up for fall opening. And so we've been in communications with a lot of different schools. The EPA also sent a memo out to all the K through 12 schools in the state of Ohio, suggesting that they take a look at their water systems. So K through 12's really got the spotlight right now, I think, because there's such a ramp up. A lot of them closed down in March with COVID, and sat stagnant for an extended period of time beyond what they normally would with summer vacation. So there was just a lot of spotlighting around the K through 12s, and it's still going on right now. But they're certainly not the only buildings that should be concerned or looking at this type of issue.
So what should facility managers be doing to prevent it then?
That is the question of the day. A lot of people are asking us that, and the tricky part with it, the thing that we always suggest, ASHRAE 188 has a standard out there that speaks to building water systems that could potentially present risk for Legionella bacteria growth. And really what facility managers and people who operate buildings should do is they really should start by taking a look at their water systems and creating a water management plan. There's a toolkit out there on the CDC website. It shows you a high level view, how to put a plan together, what kind of steps and processes should be evaluated when you're putting a plan together. But it really gets down to the preventative maintenance level as well in the plan. So talking about water temperatures, where are we maintaining our tank temps? Are we really checking those things on a regular basis to ensure that we are producing the hottest water we're allowed to? Are our circulation pumps operating properly and pushing the water through the building as it's designed to be done? Are we using the fixtures in the building? Are we actually flushing water through the building on a regular basis, or is the water being allowed to age in the building? So if you think about the impacts of COVID on water systems, domestic water in particular, we've had a few schools, just an example, that we walked in to do an assessment. We were looking at their cooling towers. It's a client that we've had for years. And we walked through the building to get to the roof access. Well, their HVAC system had been having problems, so their building temperature was probably around 85 degrees. No one was in the building, so it wasn't a huge deal. However, the water systems weren't in use at all. So the domestic water systems were sitting there. The cold water was heating up from what would be, low 60s, upper 50s coming from the city. Now you've got a stagnant line that's been sitting there for weeks, months, heating up to 85 degrees, which is a prime temperature for that bacteria to reproduce and grow. Okay, and so if we're not flushing water through the building and that water becomes same as ambient building temperature with no disinfectant in it, we start to form biofilm in those systems. And once you have a biofilm, even if you start flushing those systems prior to people returning, a lot of times that biofilm isn't removed, and it's basically a home for the bacteria to hide from disinfectant that gets put in from the city. So I would say, from a building management perspective, facility manager perspective, having a water management plan in place. If you haven't been doing any flushing since COVID started and the building has been less occupied than it normally would be, really the only way that you can find out if the system is in good standing before people return is to do some sampling and assess the system. Otherwise, you can certainly put yourself into a position where people can come back and get sick. And the other thing about the bacteria is it's particularly harmful to certain demographics. So we're typically working a lot with hospitals and assisted living because the populations in those buildings are much more prone to contracting Legionnaires disease and not being able to fight it off because they're immune compromised, they're elderly. Other folks that are impacted are smokers, people with COPD. So K through 12s, when you think of it from a student perspective, most students are very healthy, good immune systems. So they're not in that really risky population when we talk about K through 12s. So that's another thing to consider is what's the demographics of the building? What kind of risks do I have with my staff or with the people that are, occupying the building and using those systems?
Okay, so you answered my next question on, how do you know if your water's safe? It sounds like if you have any questions or in doubt, you need to have it tested. So how are you guys helping facility managers right now? Do you have a process in place that you're going through in a facility? And then I guess what needs to be done when they do have a positive test for Legionella?
Yeah. So right now we've kind of crafted an approach that we've been using since last year. We really got ramped up with a lot of case investigations and outbreaks in assisted living facilities, and we developed a process by collaborating with the Ohio Department of Health and the Ohio EPA. So what we do is kind of like some of these other guys. I mean, we're really following some standards and practices that are put in place by CDC and Ohio EPA. The folks that are really driving the studies and the research around these types of things. So the first thing that we typically do is we'll come on site and we'll do a CDC Risk Assessment. You can actually find that document on CDC's website. It's I don't know how many page document, probably a 20-pager, but basically we walk the entire facility. We're going to start in the mechanical room where the water comes into the building. We're going to look at things like water temperature, chlorine residual, and what we're going to do essentially is map that plumbing system out. We're going to look for low flow areas. We're going to look for stagnation. We're going to look for weird temperatures, cross connections, and what we typically do during that assessment, if the client would like us to do testing, is we do that testing while we're doing the assessment. So we'll assess the building. We'll, compile the CDC assessment. It's a risk assessment for Legionella specifically. And then from that assessment, you can actually start to craft your water management plan. So we talk to folks about flushing systems and, helping put those things in place, PMs on hot water tanks, flushing hot water tanks, filtration on water systems. Do you have it? Don't you have it? How often is that being looked at? But typically during that walkthrough, if we're going to be conducting samples, we will collect those while we're on site. Once the samples are collected, it's typically a 7 to 10 day holding pattern while those results are being cultured by a CDC certified lab. I will say that 50%, the statistics show that 50% of buildings, period, it doesn't matter what type of building, 50% of buildings do have this bacteria in it. Not all Legionella is the same. That is also why it's important to have a Legionella culture done, because when you develop a Legionella culture, it will tell you the species and strain of the bacteria. There are some Legionella bacteria out there that exist that are not pathogenic. They do not hurt people. They're not associated with human illness. So when we see those types of bacteria, it's just kind of like a normal bacteria. It's nothing to be alarmed about. When we see the bacteria that are associated with human illness, then we immediately suggest doing a disinfection of the plumbing system. Just to essentially knock down the sessile bacteria, which is the bacteria that's swimming throughout the system. And it's typically easy to kill. The problem, however, lies in the biofilm that I mentioned before. If you have a large growth of biofilm in your plumbing system, typically a one-time disinfection will not eradicate the biofilm as well. So you can have a repeat colonization of the bacteria. The other things that we look at during the assessment are also incorporated in the response to the results. So if water temperatures aren't where they should be by design, we get with facilities, hey, what do you guys need to do with your domestic hot water heating source, whether it's, a hot water tank or instantaneous unit. Are they calibrated? Are your sensors working right? What do we need to do to generate the hot water that we need to have? What do we need to do to flush? Do we need to have aerators on all of our sinks? Can we remove them? Because that is also a localized point for bacteria to grow. So we look at disinfection of the system, but then we also take a look at kind of the mechanics of the system and where can we improve the functionality of the system as well.
Okay. We had a couple questions come in. Let's see here. Tammy asks, we shut down our water fountains. Should ice machines also be shut down?
I mean, if the ice machine's not in use, I would say it would probably be best to shut it down and isolate it. However, it's kind of a double-edged sword, because then the water line that is feeding that ice machine is now a dead leg. So when the ice machine is reactivated, you could potentially have water in the line that feeds the ice machine. I would say if the ice machine could be set up to be almost used as if it was in service, I would keep it running and just unload the ice. There's filtration available for ice machines. It's a point of use bacteria filter. It's FDA approved 0.02 micron filter that can remove viruses from water. We have a lot of clients that look into doing that. That's typically in the healthcare market, again, due to their population. The other thing to consider when we talk about shutting systems down is how do we want to bring them back online? So if I shut down a water fountain and the water line, again, feeding that fountain has been sitting there stagnant for 6 months, I'm not concerned about the fountain. Now I'm concerned about the plumbing behind the wall and what's growing inside of that plumbing and what's going to come out when we turn the water back on. So the best thing to do really is to keep the water moving through the building the best that you can as if it were fully occupied. And doing that on a regular basis. If the systems have sat stagnant since March, let's say we just have a building that they shut down, we haven't done anything, they mothballed it, we're all working from home, we didn't do any flushing, our first suggestion is going to be to get in and pull samples. If the samples look good, then I would institute flushing right away on a weekly basis. If the samples look bad, then we would want to disinfect and then institute a flushing protocol to make sure that the water is being used as if the building was actually occupied.
Okay. Got another question for you. Has the COVID virus been shown to spread in water?
I actually don't know the answer to that question. I was talking with a couple of the guys that I work with. There is some folks doing some research on that right now. I know they're specifically looking in the sanitary discharge, the wastewater coming out of buildings going to wastewater treatment plants, to see if that is a transmittable source for COVID. I don't know that there's enough analysis out there on that now to prove whether that is or not. And I don't know that for sure on drinking water as well. I would say, that if a standard disinfectant for cleaning surfaces, like what the first two gentlemen were talking about, is effective at killing the COVID bacteria, that the disinfectants used by our city water suppliers, which is typically chlorine, should be effective at killing that as it's flowing through the water distribution system. The other interesting thing about stagnant buildings is, as we see less water usage in buildings, that also means less water usage in the water distribution coming from the city. So we can start to see problematic issues in the distribution that's supplying buildings. Purdue University is actually doing a study on that right now with a local school. We're going to be involved with it, and those results, as we get through this, will be publicly shared. But what we found was, with this particular school being down due to COVID since March, they had aged water in the building. They had issues in the building, not just bacteria. They started seeing metals leaching from the piping. They started seeing, other things that were coming into play. The city got involved, and they were testing out of the fire hydrants around the school that are on that same main that serve the school. And they were finding that the city water had started to become stagnant as well, because the school wasn't pulling the water through. They had flushed 22,000 gallons of water through this high school in one day and got the chlorine residuals back up to a great level, about 1.5 ppm throughout the distribution of the school, came back in 24 hours later, and all that disinfectant was gone. So what that tells you is there's a biofilm that has grown in that piping system that is consuming that chlorine so rapidly that it can't effectively keep anything in check. So that's why flushing is such a huge piece of the puzzle for what we do. Keep the hot water hot, keep the cold water cold, and keep it moving through the building.
Looks like I got one more that came in from Mark. Is water in dead branches or little used branches an issue if the building has continued to be conditioned to a temperature in the 70s?
There's a lot of different schools of thought on that. Our particular view and what we have seen through some of the testing that we have done is that, yes, dead leg branches of piping can ultimately present a problem for your primary system. So if you have a 10-foot run of pipe, for example, let's just say it's a 1-inch pipe that used to go to a restroom that got turned into an office, but the piping is still in place. The bacteria will grow inside of that dead pipe because there is no fresh water getting into it with any disinfectant. What then happens is the bacteria literally doesn't just stay there, it will swim and it will get out to the edge of that dead leg pipe and launch itself back into the primary system. Then it can implant itself in other areas of the facility where the water is in use, and it can grow and thrive as well. So we always encourage folks, if you're aware of branches of piping that are not in use anymore, to cap those back as close to the main as you can. That way you've got no dead areas of piping.
Okay. Switching gears a little bit, going up to John. John, the question earlier about residual value, I'm not sure if maybe we answered that completely. A question came in. I think he wants to know more about the microbial products, similar to what your company's using, working for 30 or 90 days. Can you talk about that?
Yeah, there's so these just kind of came about in the last few months, and I think they're finding now, and there's not 40 years of testing on them, unfortunately. So they're we run into industrial hygienists and nurses and doctors who have a lot of questions about it, and because there aren't 50 years of study, there's a lot of questions still. All the preliminary tests are very positive, and I think that's why like American Airlines was just like yesterday or the day before, and that's made all the news. I think we're going to find out that a lot of these, as they continue testing, they're going to find out that they are effective against similar viruses, and again, like I think Steve and Brian had both mentioned before, we're also looking ahead too. It's not just COVID-19. A lot of people believe that this next school year is going to be a lot better than other school years because all the other things that these kids have gotten, now we're protected against them because it's just a side effect of protecting against COVID-19. So back to the question. So we are very convinced that there are products out there, and we're using a couple of them that have residual effects. And again, you still, and some of these are, and most of these are effective even with routine cleaning because they're bonded to the surface. So unless there's a lot of abrasion, they will remain on the surface for, some claim up to 90 days. One of the ones we're using them, they've got tests up to 90, but their claim is only up to 30. So yeah, we're pretty convinced that there are other products out there besides the list N disinfectants that are even safer to use than disinfectants and have the same efficacy.
Okay, Brian, we've got a question for you. Please comment about upper room UVC versus HVAC mounted, and then also UVC versus ionization.
Yeah, so upper room UVC is going to be more like a technology that's a room by room type device. So it's generally for smaller type room, above 7 foot in the ceiling, so above the breathing zone. And generally what that's doing is pulling the air into it and spin it back out and running it through that UVC light. And then inherently that is, as air moves within the space, making its way to the breathing zone in a more effective way, or a safer way. Generally what UVC in an air handling equipment would be, it would be a lot similar to a T8 or T12 type tube bulb in the space. This type of light is not light that should be in the room, that's for sure, especially for periods of time. But even there's going to have to be some safety measures in place for your equipment once that would be in there. If anybody's going to do maintenance there, you'd not want that light on, because it wouldn't be good for their eyes or their skin. Generally that's a tough thing to get by on the UV side, because it's a safety risk for another way. UV, I kind of touched on this too a little bit about UV and ionization. UV is a passive technology, so because it's in the air handler, the air would have to pass through it, or I should say the virus, the bacteria, the germs that it's trying to kill would actually have to pass over that light, be there for a dwell time or a kill time as well. Within the equipment, ionization is an active airstream purification, so it is emitting electrically and negatively and positively charged ions into the space that are making the particles and molecular level in the air larger, so that they can be filtered out. So that's kind of the high quick level on it, but comparison.
Brian, do you also want to talk about the active UVC technology versus the passive?
Talking like the
RGF products?
Mm-hmm.
Yeah.
So yeah, there are a couple proprietary products out there that are a combination of what we would see as UVC and ionization. PHI, so photohydroionization, is one of those, and REMI is another. A lot of those will be more for smaller systems. They can go within the ductwork, as far as within the mechanical systems, but not within the space, if that makes any sense. Ionization as a whole gives a little bit more performance, in our opinion, that it's going to do a lot more cleaning. It's going to resolve some odors within the space. It's going to kill VOCs and formaldehyde and other byproducts, and also has no harmful byproducts of its own. There are a lot of products out there that might create different things like ozone that might not be good for us for other reasons. So ionization, we feel, is a product that doesn't do that and has no harmful byproducts, and is good for the long haul. It's going to fight off all kinds of viruses, including, for schools, flu season hits, and especially with this current pandemic, the symptoms of the flu season are the same symptoms of COVID-19. So it's going to be a very hard thing to combat, and ionization and UVC are both going to help during that time period as well for the long haul. So.
Then I'll add one of the things what Brian's saying about the differences. So on the UVC side of things, whether it's the active or passive, you're going to have to do maintenance on most likely a yearly, if not every 2 years basis, of changing out those bulbs. And each one of those bulbs, they're not necessarily cheap. So you've got that maintenance costed all the time. The UVC technology does over time start to degrade your plastics and other materials within your HVAC system, so you have to be really careful about that as well. On the ion side of things, they're fairly maintenance free, actually. Now there are a couple of things that you need to be careful of. There's some companies that are more inexpensive, and then there's companies who are, you're paying for what you're buying. So some of the ion products, they don't produce as many ions. So the more ions that a product is producing, the better. And then some of the products are also not self-cleaning. So the line of products that we provide are self-cleaning products, meaning they have little fiber brushes and they're constantly cleaning themselves so that they will last longer, and the effectiveness stays at the maximum level longer as well. So those are two really important things if you're looking into ion technology. But as far as the maintenance goes of those, once they're installed, you may have to change those fiber brushes years down the road. But other than that, they're built to last 10 to 15 years. So do we have any other questions? please speak up if you have them or type them in there. We've got a little bit more time here. John, Brian, Steve, maybe you guys can type in that chat box your contact information in case somebody wants to contact you directly. They can see that there.
Okay, will do.
Okay. Just in case you are trying to ask a question, please remember that your mics are muted so that we do actually get your question. Mark, well, actually just Mark Edwards, you seem to have several questions. I don't know if you have any more for our group. Trying to see who's all still on here. Maybe I'll just go down this list real quick. Angela, any questions? We'll see who's actually still paying attention to us. Okay.
You're looking through that. I think from the associate side, I don't know how many facility managers, but we're all realizing that this is kind of a two-step thing. It's you as a facility manager, you've got to have knowledge and proof, and you've got to know what's working. You got to know what the options are, and it's a multi-fold. Then you also have to communicate that to your occupants. And that's a bigger part. Like we're talking to so many facility managers, and they are absolutely convinced that what we're telling them is good, effective, prudent, valuable, but they've got to have a different way of communicating that to their building occupants. And it's a really interesting dynamic, because it's not, the reason we're having this discussion is because there is no absolute black and white way of doing this. Like every building is different, and everyone's got their own protocols. So it's what you believe, what you can prove, and then how you can convince your building occupants that, hey, it's safe to come back, it's safe to be here, we're doing everything we can. And a lot of it is just, it's going to be common sense. And I'll tell you this from personal experience. We have a lot of places taking people's temperature at the door, thinking that, okay, that's it. Well, I'll tell you, I got COVID 3 weeks ago. My temperature never went above 98.2. So just be careful what you believe and what you hear, and just, use your common sense.
I think the CDC did just come out recently and say that temperature is not, or maybe that was Dr. Fauci, that temperature wasn't necessarily an important aspect to determine it. So, like with all of the things we've talked about today, every day there's something new that comes out and changes what we're all looking at and focusing on. So I think that's a good point, that we're trying to be the experts in the fields and trying to have all of that knowledge for all of the facility managers out there, so that you have maybe one less thing to worry about, and you can just call your trusted partner. So I wanted to go back. John, you had a question or Mark had a question for you of how many customers do you have that have day porters that are disinfecting conference rooms after each use?
That's a great question, Mark. We have, and I don't know where they're coming up with the money for this, but we've got several locations where, like the first one to do it, are just to get you the scope, we had either 3 or 4 people. That was the nightly cleaning crew. We added 10 people during the day to just go around and wipe things down. And these are areas where, they might only have 1 or 2 employees in a manufacturing environment, but we would have one person going around, for every 2 or 3 hours, hit the same spots that they hit before. And it's a thankless job, because when you paint a room, you see when you're done. When you wipe something down that's already clean, I feel you feel for these people doing the job. But Mark, we've got schools now, a lot of schools who have had us bring on extra day porters, and their job is to be very visible and go around and wipe things down, hit the touch points, and it's effective. But between all of us, a lot of this is being visible and making people feel comfortable. If you're a school and you can get 5 more parents to get your kid to come to school that wouldn't have, and you can get 5 more teachers to come back to work, that's a lot of money, and that's the way they look at it.
And one thing to think about for those on the call with facilities, there is money out there available to help you with things like, hiring somebody to do your disinfecting services, or, increasing your filtration, your water treatment related to this, air purification devices, that type of stuff. So specifically, Montgomery County's running grant opportunities right now. If you're in the manufacturing side, there's a group called Fast Lane through the University of Dayton, I believe, that has money out there. School districts, they specifically receive money for COVID-related expenses. So there are some funding sources out there that any of us would be probably happy to discuss with you and help you with if that's something that you're looking at trying to take advantage of. We did have another question come in. What are you doing in buildings that are occupied but very low occupancy as far as cleaning cubicles and offices that have not been used that day?
Well, one of the things a lot of our customers are doing is they're creating isolation zones. So what they've done is they've taken their facility and subdivided it into maybe 4 quadrants. And they've done that with our employees as well. So employee A and employee B, they are only in this quadrant all day long. They use a lounge in that area. They use a restroom in that area. They aren't allowed to cross the other lines. So if something does happen, they know that 3/4 of that building is not going to be affected no matter what. So that's one of the things they've done. I'm sorry, what was the exact question again, though?
The exact, what are you doing in buildings that are occupied but very low occupancy as far as cleaning cubicles and offices that have not been used that day?
Yeah, it is. A lot of this is coming down to money. We've, and if you're in the custodial or whatever industry, as people reduce their occupancy, they're just asking us to clean less. Now, obviously, you need to hit the surfaces that are going to be touched all the time. So, hopefully, whether you have 100 people or 1,000 people, if every one of them have full access to the building, you've still got to clean everything you did when there were 1,000. So, unless you are actually vacating spaces, which would still need to be, dusted and whatever, common areas, everything else, it's just because 10 people are touching it instead of 100, it's nothing will have changed.
So Brad, you mentioned having water and ice filtration units that have UV and canister filling systems, and you have some information. So there's an attachment option there in the chat function. You should see like a little paper clip underneath where it says type a new message. Speaking of that, I know that there is a product that can be added to like ice machines. It is like a small UV unit. It's not very, it's not very big. Maybe less than a foot tall, I'd say, that can be added to ice machines that is filtering those systems as well. The UV light inside of it's killing, things. So I don't know, Steve, if you have any comments on that as far as a good method. I know that that's one of the products that we offer is a unit for ice machines.
Yeah, we with UV, it's the same as air. The water, because we've looked at putting UV on domestic cold water and things like that. The water has to pass through that unit, just like air. So in order for it to have that effective kill, it's got to make it through that piece of equipment. Ice machines are particularly tricky because even, before buildings became unoccupied, if an ice machine's not in use, the compressor on the back is warming up the water line that's feeding the unit. So you're effectively removing the disinfectant with a carbon filter that removes chlorine due to taste. You're heating the water up and you're providing an environment for bacteria. So we've got some point of use filters in our line of products as well that literally replace the existing filter system that comes on the ice machine. It's an inline unit. It will remove viruses. We've done studies on those. We also have those available for sinks. So when we have a case investigation, or if someone has an outbreak, or if they have bacteria in the water in a hospital, for example, we can go and put filters on the sinks and showers in patient rooms so they can still occupy and use that space and know that they're getting safe water. So with ice machines, Yeah, taking a look at your filtration is kind of a, I wouldn't say a newer thing, but we're seeing a lot more traction in the healthcare industry with really taking a look at the way they're filtering the ice machine, mainly due to waterborne pathogens, and looking at a way to reduce the risk with ice. You wouldn't think that that bacteria would grow in ice, but there are studies out there that show that it can live in ice. And the typical issues with ice, again, is going to be a healthcare related cases, because ICU patients that can't eat chew on ice chips. They aspirate the ice. If it's got bacteria in it, that's how they get that bacteria. So again, a lot of it's demographics for us. So, what's the population of your building? Who's using the water systems? Do we have an at-risk population? It's awareness as well. Do the people that come in and out of our buildings, are they aware that if I get diagnosed with pneumonia, that I probably ought to also ask them to check me for Legionnaires disease, because it's the exact same symptoms. It's not treated the same. So once a human acquires Legionnaires disease, it's very treatable as long as they know that that's what they're treating. They just have to treat it with the right drugs. So, it's just education and awareness. So, but yeah, we've got some filtration. I think UV is a very effective method as well, as long as it's applied properly.
I know another thing that we've been talking to some customers about is actually drinking fountains themselves. So there's a couple different things that you can look at drinking fountains. One, you can get a touchless drinking fountain, so you're not pushing buttons anymore. You wave your hand underneath of it. So that is one option. Another option we've seen some people go with is they have existing water fountain, maybe push buttons, and they're adding bottle fillers to the top. So that way, one, they could use both, but potentially what they're doing is they're turning off the water fountain piece and just using the bottle filler piece. So there are retrofit kits to existing water fountains that you can get, so that people can still get their water, but doing it in maybe a safer way. So they're not touching and I don't know. I have a little 8-year-old, and I swear every time he gets near a drinking fountain, I think he like licks the bubblers thing, So I'm sure, all being in the schools, you see it all the time, that it's not the healthiest of a setting, but definitely there's some options like that as well. Just a heads up on all of these products we're talking about today, lead times. There's some pretty significant lead times on things. I know, like on filters right now, MERV 13 filter media, for instance, is a major lead time issue for every single company out there right now. The media that they use in MERV 13 filters is the same media that's used in the masks that they're making, and it's also the same media that's used in baby diapers. So there's a lot more money out of those products than there are necessarily out of certain filters. So they're kind of switching some of that filter media out, but that MERV 13 filter is running some longer lead times, as they're trying to ramp up production. Also, we're starting to see just MERV 8 filters in general are starting to slow down. I know the UVC products, a lot of those are running anywhere from like 8 to 12 plus weeks lead time. Ionization products still seem to be about 2 weeks lead time. Those drinking fountains I was just telling you about, we're seeing anywhere from 5 to 12 weeks lead time on those. Some are a little less. So I don't know if you guys have some comments on some of the cleaning chemicals, if you don't have a stockpile, what that looks like. And I don't know water treatment, how that's impacted you guys.
Well, the sanitizers, I mean, that since day one, and clearly the wipes, all that stuff. We had a customer who bought a lot of sanitizer. It was 70% alcohol, and he thought he was set. And the fire marshal came in and said, "Wait, you got 70 gallons of this or whatever sitting in one room." He didn't know he had a bomb sitting there. So you got to be careful where you're storing this stuff as well.
Yeah, we've not really seen an impact on a lot of the products that we would use to disinfect a water system, for example, is readily available to us. The filtration that we would suggest is available. We have it in inventory as well. So a lot of the stuff that we would use on the domestic water side, we're not seeing anything. We've seen some slowdown on some specialty equipment, but none of that's really going to be impacting what we're talking about today.
Well, I want to thank everyone for joining today. I think all of the contact information is in the meeting chat. I did fail to start the recording at the very beginning, so we will post the recording from where I started it. If you have any other questions, you did get a meeting invite from me, so feel free to send questions and I'll get them to the right individual on the panel today if you would like. Other than that, thank you for coming and we appreciate your time and have a great weekend.
Thanks, Christy.
Thank you.
Thanks, Christy.